guys, today I will show you on how to solve the question using the method of coefficient linear in the two variable. I have a question here. So the question says, so solve x plus y minus 2 dx minus x minus 4y minus 2 dy is equals to 0. So for this method, the first step is to find whether both of these equations intersect. So we write check both equation if intersect. So here we can check it easily by using the method of the straight line. So x plus y minus 2 is equals to 0, and negative x plus 4y plus 2 is equals to 0. So we shift all the non-y term to the right side. We get 2 minus x. I denote this as y1, and this one y2. 4y2 is equals to x minus 2. y2 is equals to 1 over 4x minus 1 over 2, because 2 divided by 4 is 1 over 2. So now we already see the gradient of y1 is equals to negative 1, and gradient of y2 is equals to 1 over 4. So from the knowledge of the straight line, we know that when the gradient is negative, the slope is here, and positive, the slope is up. So here we can see that it obviously has the intersection point. So the step number 2 is to find the intersection point. Find intersection point. So we can use the method of elimination or substitution. So in this case, I will use elimination because it's much more easier and shorter way to solve it. So I denote this one as the first equation and second equation. So I plus it because I want to eliminate the x. So x minus x is 0. Y plus 4y, get 5y is equals to minus 2 plus 2, 0. So we get our y is equals to 0. Then now we substitute y equals to 0 into the first equation. You can also substitute into the second equation, but I found it is more easier to substitute in the first one because it's only require a very simple way. X is equals to 2. So now we find our intersection point, which is equals to 2 and 0. So now we already find our intersection point. The next step is to let x equals to u plus something and y is equals to b plus something. So here we let x equals to u plus, where do we find the value of a constant here? So we already get our x is 2, so we just write u plus 2, and for y we plus with 0, or you can write it as y is equals to v. So now you just have to substitute the x and y into the original equation. So now we start to substitute it. So u plus 2 for x plus y. Okay, before we substitute, we need to find the differential for x and y. So this one is du, and for dy is equals to dv. So u plus 2 plus y plus v minus 2 dx is du minus x u plus 2 minus 4y minus 2 dy equals to 0. So we simplify it. Here we can cancel out. Here we can cancel out. So we get u plus v du minus u minus 4v dv is equals to 0. So now we can solve the remaining equation using the method of homogeneous. So step number 4, solve using homogeneous equation method. So for homogeneous, we need to denote first the u and v for n and m, because our term is in u and v, not x and y this time. So m uv is u plus v, and for n we have negative u plus 4v. So we do the homogeneous way, ku plus kv, then we factorize out the k, get u plus v, which is also equals to kuv. Okay, for n, so n ku kv, ku plus 4kv, so factorize out the k, get negative u plus 4v, so which is also equals to knuv. Therefore, we can show that these two equations, both equation are homogeneous at degree 1. So now we proceed to the homogeneous method, which is let u equals to vw. So our du will be du will be v dw plus w dv. Alright, so now we just have to substitute it inside the new equation here. So our u is now substitute with vw. So we get vw plus v du plus w dv minus u minus 4v dv is equals to 0. So now our equation with a new term, which is w and v. So now we simplify it, we will get v square w dw plus vw square dv plus v square dw plus vw dv minus vw dv plus 4v dv is equals to 0. So here we can cancel out. Then we gather all the dw and dv. So for dw plus v square dw plus with vw square for dv plus 4v dv is equals to 0. So now we can factorize out the v square for dw and v for dv. So we factorize out, we get w plus 1 dw plus v w square plus 4 dv is equals to 0. Then we can factorize out again the v. So v, we left with vw plus 1 dw plus w squared plus 4 dv is equal to 0. So we shift this to the right side, then we will get our equation into this form. Now we can easily separate the variable. I hope you can see it clearly. So we separate the variable w plus 1 over w squared plus 4 dw plus 1 over v dv is equals to 0. Then we can shift this 1 over v dv to the right side. So we get w plus 1 over w squared plus 4 dw is equals to negative 1 over v dv. So now we need to integrate both sides. So click on the new page, write down again the previous one. So we can integrate w plus 1 over w squared plus 4 dw is equals to integration of negative 1 over v dv. Okay, so we can first separate this equation into a simpler form. So integrate w squared plus 4 dw plus 1 over w squared plus 4 dw is equals to, so when we integrate negative 1 over v, we get negative ln v plus c. So now, in order to integrate these two integral, now we integrate w over w squared plus 4 first. Because this is, we can use the technique of integration, which is substitution. So we let u equals to w squared plus 4. So du is equals to 2w dw. So we can see here our equation only requires w dw. We don't need the 2. So we shift it on the other side. So we can now integrate our w over w squared plus 4 dw, which is also equals to, so we just have to substitute the u where is equals to w squared plus 4, we get u. So our du is, our w dw is 1 over 2 du. So when we integrate it, we will get 1 over 2 ln u plus c, which is also equals to ln. So we substitute back our u, which is equals to w squared plus 4 plus c. So we are done for the first integral. So the next integral, w squared plus 4 1 over w squared plus 4 dw. So for this one, we can use the technique of integration, which require the trigonometry substitution. So for this one, we can write it as w squared plus 2 squared 1 dw. So we let w equals to 2 tangent theta. So our dw is equals to 2 secant square theta. So now we just have to substitute this inside. So we get integrate w W is 2 tangent theta square plus 2 square, or 1 over, and our dW we times with 2 secant square theta Okay, so now we just have to simplify it. So write it nicer. Sorry, here is d theta. So 2 secant square theta over 4 tangent square theta plus 4 d theta. So we can factorize out the 4 and we will get 2 secant square theta over 4 tangent square theta plus 1 d theta. So the trigonometry identity, tangent square theta plus 1 is equals to secant square theta. So now we can simplify this as 2 secant square theta over 4 secant square theta d theta. So we can cancel out this, simplify this, and we get 1 over 2 d theta. So we will get 1 over 2 theta plus c. So now we need to substitute our theta back into W. So we have W is equals to 2 tangent theta. In order to find the theta, we shift all the unuseful one to the side that we don't want. So for this one, we get inverse of tangent W over 2. So substitute it inside, we get 1 over 2 inverse tangent W over 2 plus C. So now we can write back this integration. So we have W over W square plus 4dW plus 1 over W square plus 4dW is equals to negative ln V plus C. So we just have to copy back the integration. So 1 over 2 ln W square plus 4 plus 1 over 2 inverse tangent W over 2 is equals to negative ln V plus C. So now we shift the ln, negative ln V, the negative ln V to this side. So 1 over 2 ln W square plus 4 plus 1 over 2 inverse tangent W over 2 plus ln V is equals to C. So now we already integrate both sides. Now we just have to substitute back our W and V into the X and Y term. So we substitute back our U in front. You can see here U is equals to VW. So we just substitute U is equals to VW. So we want it in W, so W is equals to U over V. So our U here is this one. Let me focus. Okay, so this one and this one we just have to substitute back. So we will get our U. U is equals to X minus 2 and V is equals to Y. So our W is equals to X minus 2 over Y. Okay. So So now we just have to substitute back. So we will get 1 over 2 ln x minus 2 over y square plus 4 plus 1 over 2 inverse tangent x minus 2 over 2y, because here got 2, plus ln y is equals to c. So we simplify this one first. We get 1 over 2 ln x minus 2 square plus 4y square over y square plus 1 over 2 inverse tangent of x minus 2 over 2y plus ln y is equals to c. So now we times the whole equation with 2. So we get ln x minus 2 square 4y square over y square plus inverse tangent of x minus 2 over 2y, 2 plus 2 ln y is equals to c. Because 2 times c is still a constant, so I'll just write c. So for this one, we can use the ln property, which is equals to ln y square, and you bring this power up to here. So we will get x minus 2 square minus 4y square over y square plus inverse tangent of x minus 2 over 2y plus ln y power of 2 is equals to c. So the ln property also said that if we have the addition of 2 ln, we can make it as product. So for here, y square and y square, so we can cancel out. So we left with ln x minus 2 square minus 4y square plus inverse tangent of x minus 2 over 2y is equals to c. So our final answer for the equation is ln x minus 2 square minus 4y square plus inverse tangent of x minus 2 over 2y is equals to c. That's all from me. Thank you.